So this morning, let's look at the square root of -27. Now in the past, if you can recall, I said that you cannot take the square root of a negative number because there's no two negatives that will multiply to give a negative. Well, that wasn't really true. We can. But in order to do this, you need something called an imaginary unit. All right. So let's talk about let's do the title. The title. Imaginary numbers. Well, let's do this. Imaginary and complex numbers. All right. So when you're looking at imaginary numbers, let's talk about the imaginary unit. All right. So the imaginary unit the symbol is a lowercase I. All right. This represents a number whose square root is -1. So, I is the square root of a -1. Also, that means I to the second. So we said if I is square root of -1, I squared is 2 i's, right? Which means I times I, or -1 times -1. And anytime you have 2 of something, right? Anytime you have 2 of something, for a square root, you have 2 of something, that something can come out. So the square root, so I squared is equal to -1. All right. So let's go back to that -27. The square root of -27. So, for an example, the square root of -27, is, okay, we say 9 times, well, let's go back. About to get into some wrong. All right. So, let's take the square root of -27. All right. What you do is, you know that -27 is a -1 and a 27. So, when you see this the square root of -27, it's okay to separate that square root of -1 times the square root of 27. See that? Now, I've already told you that the square root of a -1 is the imaginary unit I. All right? So we know that this is going to be, that's going to be I automatically. We break down to 27, 9 and 3, and 3 and 3. The 3's come out, 3 left in. So you're left with I times 3 square root, what's left over in there? 3. Let's fix that. Let's put that in standard form. All right. It is written 3 imaginary unit square root of 3. See? So for any number, for any real number, you can have imaginary unit in any real number. So So any number, you can take out that imaginary unit to make that square root a positive. All right? Well, the Radicand positive. Let's do one more. Of negative 50. And let's put a negative 6 on the outside. All right. All right, let's see. I like that. Let's zoom in on that. All right. The first thing I would do, I know to have a square root with a negative Radicand. Let's separate that. All right. So negative 6 is still going to be there. But under the radical, I can take out that negative and say negative 1. Separate that. And the square root of 50. See that? And we know that the square root of negative 1 is an imaginary unit I. Alright? Only thing we got to do is break down this 50. And whatever we pull out, we're going to go with that. We're going to put it with that negative 6. Alright, 50. 5 times 10. 10 is 5 times 2. 5 comes on the outside. We're going to put it all the way out here. On the outside of both radicals. Alright? So, what do we have? We have 5 times negative 6 is negative 30. I. What's left in the radical? 2. Alright, let's look at some practice problems. Alright, so using what we just learned, everything, try to complete these 6 problems, the directions. Let's go to the next part. Complex numbers. All right. Wait a minute. Where's that line? Oh, yeah. All right, let's go to the second part of imaginary complex numbers. Specifically, complex numbers part. All right, complex numbers. These are numbers that can be written in the form of A plus B times the imaginary unit, where A and B are both real numbers. All right, this is the standard form. Now, again, A, this is the real part. You know, like real numbers. It's the real part of the complex number. And the BI part is the imaginary part. All right. Now, before we get too far, let's go over some powers of I. All right. So you won't have to calculate it all the time. So let's go over the powers of I. We already know that I is the same as square root of negative 1. We also find out that I squared is just negative 1. I cubed can be simplified to I squared times the I, which is negative 1 times I, which is negative 1 . I was going to say negative 1I, but it's just, you won't write ones in math, we'll just write negative I. All right, negative 1I or just negative I. All right, I to the 4th power can be simplified to I to the 2nd, or factored, I should say, factored to I to the 2nd times I to the 2nd, I to the second power is what? Yeah. -1 times -1, which is 1. I to the 5th can be factored to I to something we know. I to the 4th times I, which equals, we say I to the 4th is how much? A +1. And I is just I. So 1 times I, it's just I. You don't need the 1 in the front. All right. I to the 6th. Let's spread it out. So what's something we know? All right. You can get 2 3s. You can get a 4 to 2. Let's do a 4 to 2. I to the 4th times I to the 2nd. When you factor it out, we know I to the 4th is just I. And I to the 2nd is -1. So I to the 6th is also I'm tripping. Let's go back to that. I to the 4th here. No. I to the 4th here is 1. While I to the 2nd is -1. Which means that I'm tripping. Hold on, I'm tripping. Let's correct that back up. All right. So I to the 6th is back to I to the 4th times I to the 2nd. And we know I to the 4th here is 1. And I to the 2nd, I to the 2nd is -1. 1 times -1 is -1. So just keep going. I to the 7. I think you get the idea. I to the -7. I to the 7 is, we got a 6. So I to the 6, we factor. I to the 6 and I to the 1st. I to the 6 is -1. I to the 1st is just I. That's our unit. So the answer is -I. So you should be able to see a pattern in this thing here. You should be able to. You should be able to. If you look at, what do you see about 2, 4, 6? What do you recognize? Let me check this out. Let me see. What's the pattern? What's the pattern between even, imaginary, unit, exponents? What pattern do you see? What do you see? Versus the odd. Outside of 1 versus the odd index of those imaginary units. What do you notice? All right. So when you got even powers, you have 1, whether it's -1 or +1. Anywhere you have an odd number, you have I. Either it's a -I or +I. And if you look at the pattern, let's take one. Let's take an example. I to the, let's say 26. All right, 26. All right, what I noticed? I noticed that 26 is even. So we know we're going to have either 1 or -1. Now, I see when I have multiples of 4, I have a +1. So what I mean, 26 go into 4. All right, can 26 go into 4? I mean, sorry, can 4 go into 26? So 26 divided by 4. Yep. It won't work for us, but we get 6 and get 24, right? So that means we have 2 left over. So we have an I² left over. So because we have multiples of 4, we would get a positive 1. Because we have I squared left over, we get I times negative 1. I mean 1 times negative 1, which is negative 1. Alright? I don't think I did was look at the fact that if 4 can go into a number, it'll be 1. That would be 1 time, 1 time, 1 time, 1. We got 6 of them. 1 time, 1 time, 1 time, 1, 6 times. But I got an I squared left over. Alright? Let's do it again. I to the 35th power. Alright? So there are several ways to get here. Let's use the factors of I. I like using the 4s. I like using multiples of 4. So if I had to, I would say I to the 32 times I to the 3rd. See, I to the 32 times I to the 3rd. Put that together to get I to the 35th power. 4 going to 32 1 time. 8 times. And 1 time, 1 time, 1 time, 1 is still 1. Then I have I to the 3rd, which is negative I. You still get negative I. You can do it a number of ways. If I was to the 35th power and you want to do 7 going to 35, okay, that's cool. That's cool. We can do it in multiples of 7. So let's say, what's the closest timetable to 35 for the 7? The 4, 28. So I to 28 times I to the 7. All right? 20 plus 7 is 35. Okay, cool. So 7 going to 28 4 times. So we'll need 4 I's. Four negative I's, I should say. Because 7 is a negative I. So negative, 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 negative.